This lecture gives a quick overview of the OpenGL organization, types, state machine, functions, primitives, and attributes. Modern OpenGL allows the computer program to achieve fast graphics performance by using a graphics processing unit rather than a central processing unit. Graphics processing unit is called GPU in short. Modern OpenGL allows applications to control the GPU through programs known as shaders. It is the application's job or the application program's job to send data to the GPU. You must have seen that one of the important specifications of a GPU is its memory, which means that you can store this much data on the GPU, and it is the GPU that then performs all the rendering. The OpenGL software is organized as shown in this block diagram. Basically, the application programs can use glue, GL, and glut, but they do not have direct access to the windowing function libraries because they are specific to operating systems. Hence, once you have written a program, you can recompile it using glut libraries for another operating system. Types basically mean variable types. In OpenGL, there are variable types such as GL float, GL double, GL int, which are equivalent to the C programming types float, double, and int. Int stands for integer here. And you can work out that since they have a prefix GL, they are stored in the OpenGL or they are defined in the OpenGL core library. Additional data types are supplied in the header files vec.h and mat.h, which are supplied by the author of the book, and they have additional variables such as vector2, which is two-dimensional vector, vector3, which is a three-dimensional vector, and their 2 and 3-dimensional points and matrices are defined in these header files. We can think of the entire graphics system as a state machine, a black box that contains a finite state machine. This state machine has inputs coming from the application program. These inputs can change the state of the machine or can cause the machine to produce a visible output. From the perspective of the API, graphics functions are of two types. Those that specify primitives that flow through a pipeline inside the state machine, and those that either change the state inside the machine or return state information. In OpenGL, there are very few functions that can cause any output. Most set the state, either by enabling various OpenGL features or setting parameters used for rendering. Until recently, OpenGL defined many state variables and contained separate functions for setting the values of individual variables. The last versions have eliminated most of these variables and functions. Instead, the application program can define its own state variables and use them or send their values to the shaders. One important consequence of the state machine view is that most parameters are persistent. Their values remain unchanged until we explicitly change them through functions that alter the state. For example, once we set a color, that remains the current color until it is changed through a color altering function. A consequence of this view is that attributes that we may conceptualize as bound to objects, such as red line or blue circle, are in fact part of the state, and a line will be drawn in red only if the current color state calls for drawing in red. Although within our applications it is usually harmless and often preferable to think of attributes as bound to primitives, there can be annoying side effects if we neglect to make state changes when needed or lose track of the current state. OpenGL provides a range of functions for specifying primitives, attributes, transformations, control, input, and query. These functions make it easy to perform basic graphics operations. So what are OpenGL primitives? Primitives are basic building blocks such as points, lines, a line strip, and a line loop that basically closes. Triangles, a triangle strip where the triangles are attached to each other, and a triangle fan which are a collection of triangles with one common point. Let's look at attributes now. Attributes are properties associated with the primitives that give them their different appearances, such as color, size of and width of the points, stipple pattern for lines and polygons, polygon mode. For example, we can display a polygon as filled, or only with edges, or only with vertices. Note that GL point size, the actual size that is displayed on the screen, will be different. We'll read more on this later. It is important to remember that OpenGL is not object oriented. Hence, there are multiple functions for a given logical operation. The following are the same function but for different types of parameter inputs. GL uniform 3F takes a 3-dimensional float input, 2I takes a 2-dimensional integer input. The underlying storage mode is the same. Although it is easy to create overloaded functions in C++, but the issue here is efficiency. OpenGL takes a non-object oriented approach so that it is more efficient.